trigonometric functions, and modeling with the sine function. So we've done a few Ferris wheel examples. We're going to do another one, and we're going to use an equation to model it. As the Ferris wheel turns, the height, h at x in meters, that a rider is above the ground is given by the equation. H at x is 6 sine of x plus 270 degrees plus 8, where x is the rotational angle in degrees after the ride begins. So let's get our handy dandy highlighter, and we're going to highlight the important stuff. As the Ferris wheel turns, the height, h at x in meters, that a rider is above the ground is given by the equation. H at x is blah, blah, blah. X is the rotational angle in degrees. Okay, so we know the heights in meters and the angles in degrees. We're still using our same problem solving, word problem strategies, highlighting and looking for key information. We want to sketch 2 cycles of h at x. So that's our plan here. We're going to start by graphing. Now we know the sine function starts on a 0, it ends on a 0, and halfway in between is 0. So guys, I do apologize, but my stylus doesn't work fabulous for this. So starts on 0, ends on 0. Oops, we need to get rid of that. Try that again. It starts on 0, ends on 0. Smack in the middle is a 0. Halfway between the first 2 zeros is the maximum, and I can find that because I look at my amplitude. We're going to combine that. The amplitude 6, so the maximum will be 6, and the minimum will be -6, because we know that it's normally 1 or -1 for a sine function. So that's the graph y equals sine x. Sorry, 6 sine x. Now, we can change that, or we can add now the horizontal shift, also known as the phase shift, and the vertical shift, and we take all our points and we go left 270, so 90, 180, 270, and up 8. We're going to put a point there. Take this one left 90, 180, 270, and up 8. We're at 14. Take this point left 90, 180, 270, up 2, 4, 6, 8. Left 90, 180, 270, and up 8. We're right here. Left 90, 180, 270, and up 8. We're here. We'll notice that our zeros all moved on top of the line y equals 8, which is the equation of our axes. And we know that if we want 2 cycles, all we have to do is pick up each of these points and move it right 360 degrees. So we're going to go right 90, 180, 270, 360. So we're starting where the last cycle ended. Right 90, 180, 270, 360. We're right here. 90, 180, 270, 360. We're right here. 90, 180, 270, 360. And 90, where am I? 90, 180, 270, 360, we're right here. And we can draw our smooth curve through our points. And we would also now label that y equals 6 times the sine of x plus 270 plus 8. And that's done a little neater on the next screen, so you'll be able to see that here in the note when you copy. Now, what do we ask for here? What's the initial height of the rider? We can do that 2 ways. We can use the graph, or we can use the equation. What we're ultimately looking for is the initial height. So let's go back to the graph here. Let's look at this one. Initial height means the rotational angle is 0 because we haven't started moving. And if we look at the scale of this graph, it's going up by 1s, and the initial height is 2 meters. Now, if we use the equation, it's a little bit different. We've got y equals sine of 6 sine of 270 plus x, which is 0, plus 8. So y is equal to 6 sine of 270. I don't know why I put the sine there, guys, on that other line, plus 8. If I think about my sine graph, it looks like that in general. And at 270, sine is -1. So it's y equals 6 times -1 plus 8. And y is -6 plus 8. And I also get y equals 2 meters. And because, of course, this is a word problem, we should have a sentence answer. Therefore, the initial height of the rider is 2 meters. And you'll be able to copy that better later on, copying from this screen. Part B, or D, sorry. Height of the rider after a rotation of 360 degrees. We can use the graph. We can use the equation. At the end of the day, we're looking for the height of the rider after an angle of 300 degrees. We're going to go back to the graph. And we're counting by 45s along here, so it's not going to be as easy. So this would be 315 right here. So 300 would be around there. Yeah, it might be about 4.5. It's not very exact since I don't have a perfect scale. And of course, this graph was drawn with technology, not by hand. Of course, our answers will be off a little bit when we do it by hand. So we can get a better graph. It looks like it's about 4.5 meters. Let's see how close our guess is. We've got y equals 6 sine of x plus 270 plus 8 that we're starting with. So it's 6 sine of 300 plus 270 is 570 plus 8. Well, that I need my handy dandy calculator for. And my handy dandy calculator is telling me that that's equal to negative 0.5. So 6 times negative 0.5 plus 8. And 6 times negative a half is negative 3 plus 8. And it's really actually at a height of 5 meters. And we needed the therefore statement as well for this. Therefore, the height of the rider is and we know it's exact too, is 5 meters after a 300 degree rotation. In the first method, we would have had to say approximately, right? So we can put our equal to sign with our dot above, because we can't tell what it is exactly. And again, it's written neatly here. What's the maximum height of the rider? Go back to your equation. My minimum, and I didn't have to graph it. Let's look at the equation. If I look at it, my max is normally 6 for a sine function. So if I'm stretching by 6, sorry, the maximum is normally 1 for the sine function. I apologize. But once I stretch it by a factor of 6, that 1 becomes a 6. And now everything goes up 8. So my maximum is actually 14 meters. And the minimum, negative 1 times 6 is negative 6. And I move it up 8 and it becomes 2. Of course, since we graphed it, we would never do all of this work. We would just look at the graph and find the values on the graph, because why do more work than we need to unless the question specifically tells us to? Maximum at 14, minimum at 2. Finally, things we need to remember about modeling with sinusoidal functions. If the independent variable is not in degrees, the calculator has to be in radian mode, which is a measurement we don't learn in 11 mixed. Real life modeling usually uses radian measure for the angle. You won't be doing that this semester or this year. You will do it if you continue on in 11U or college and technology math. However, we will use the graphing calculators to help us model situations where the independent variable is not in degrees. And before class tomorrow, you can have a look at number 1, 3, 5, 6, 8, and 10. I forgot to look back at them, but only do the questions where the independent variable is in degrees, or it's just asking you to graph without an equation and it's ordered pairs.